Okay, so we've been through the theory side now, in terms of questions that may be received without sort of a concept behind it or context behind the question. So I'm going to sort of throw out a potential industry-based question here that you might be presented with. So there's going to be a lot of points to it. So this will probably be spread over maybe 3 or 4 questions at least. But again, it gives you a good idea of what sort of happens in an industry scenario or what you'd be expected to know. Okay, so this spreadsheet may seem a bit complicated, but again, I like to use spreadsheets sort of so to showcase it because it's an easy to lay out the numbering. But down here, we've got a diagram of a network, and this is the information we've been given. So we've got 3 teams: a marketing team, a sales team, a production team, and we've been given an IP address of 172.16.0.0. We've also been given the number of hosts that are going to appear on each network, and these are the questions here on the left hand side that we need to answer. Okay, so as we look at that diagram, let's start from the left to the right, let's call these 3 teams A, B and C. So marketing's A, sales B and production C. So from that diagram, hopefully we remember that routers separate networks. So when the question's asking us how many subnets we require, so this question here, we're going to need a subnet for marketing, we're going to need a subnet for sales, we're going to need a subnet for production, but we're also going to need a subnet that joins these 2 routers together. So the answer to that question is that we require 4. Okay, so again, if you see a networking diagram, always count the number of hops between routers it gets between various points. So like I say, we've got 4 networks here, so 4 connections on the routers. So the next sort of question I'm going to address is the address class. So from the IP address, it's 172.16.0.0. So we know from our previous findings that this is a Class B network. So it fits in that gap between 128 and 191. Okay, so it's a Class B. So the default subnet mask for a Class B, again, should remember this by now, is 255.255.0.0, and that's using 16 bits by default. So that's the default CIDR notation. Okay, so into the question that we're going to be answering now, we're going to start looking at sort of total subnets needed. Again, it gets a bit complicated this because the company that we're looking at here is expecting 100% growth. So all we need to do is double it, so it makes it easier for us. So let's just answer this one here: largest number of subnets. So sorry, largest number of hosts. So if we look at production, that's clearly the largest number. So 60 is required on that network. So I'll put 60 as the largest because again, that's going to affect our subnetting potentially. So if we get 100% growth, we're going to need a total number of 8 subnets. 4 times 2 is 8. And then the total host need on the largest subnet is 60 times 2, so 120. Okay, so we're going to focus on the subnetting side, so we're going to need 8. So by default it's 16, so we're in the 3rd octet here. So we can't use /17 because that's only 2 subnets. We can't use /18 because that's only 4, but here we can use /19. So if I colour these green, that's going to effectively be our network addresses, and all these remain for hosts. Okay, so that's sort of a key part to this question here. So our new subnet mask we can work out now. So it's 128 plus 64 plus 32. So it's going to be 255 plus 2.255. So again, this is where we're looking in that 3rd octet. So it's them 3 numbers added together, which gives us 224, then .0, and the new CIDR notation. So we've used 13 bits. Borrowed 3 bits or used 3 extra. So it's a /19. Okay. So effectively we've answered that question there that it's asking us. Now just to sort of go one step further, so we're using 8 subnets. I'll start filling in these this address range here, because the question may ask us what's going to be our IP range for the 4 networks that we're looking at. So if I rename these, we'll call it subnet 1 is A, subnet 2 is B, subnet 3 is C, subnet 4 is the link. So I'll just put a link. So that's going to be the link between routers. Okay. Now, for us to identify the network addresses now, again, we're looking at that 3rd octet. So from here, the network addresses, the final one, is going to go up in batches of 32. Okay, so the 3rd octet is going to go up in batches of 32. So our network addresses, the first one is given to us. Okay, the second one, again, this is just network addresses, is 32.0. And the third one for production is .64. And the link is going to be .96. I missed a 0 off that one. Okay, so there are our 4 network addresses. Now we have made room for 8 because we're expecting growth, but I sort of won't put that on here, but that's going to be following on from 96, so we'll get 128, then 160, then 192, and so on. Okay, so again, like in my previous videos, I like to fill in the broadcast address next for each network. So 16.31.255. So if effectively it's minus the last network or the next network. 72.16.63.255. So again, just remember that broadcast addresses are not usable addresses. So it's always the last network, last address on the network. Okay, and then we should have 127.255. Okay, and if I put the range in there, we've got 172.16.0.1. That's going to so it's one off the broadcast address, so it'll be 16.31.254. Okay, and then again 16.32.1, and then 172.16.63.254, 172.16.64.1, 172.16.95.254, 172.16.96.1, 172.16.127.254. Okay, so that completes the whole angle of these questions might come at. So again, that might form 5 maybe up to 8 questions we've answered there, or it may have individual questions that are related to the content of each one of these stages that we've been at. But that's a big run through from start to finish on how this sort of works in an industry scenario.